China's open source AI versus the US closed source approach. The bifurcated future, a strategic analysis of the US closed source versus China's open source AI race. The global competition for artificial intelligence leadership is no longer a race towards a single finish line, but an ideological and strategical contest between two fundamentally different paradigms. The United States, leveraging its lead in high-end innovation and access to advanced semiconductor technology, has adopted a closed-source development model. This approach prioritizes intellectual property protection, centralized control, and the monetization of AI as a proprietary, high-end service. In stark contrast, China, facing significant export controls on cutting-edge chips, has embraced an open-source model as a form of geopolitical statecraft. This strategy, born from necessity, leveraging a collaborative, community-driven approach to bypass hardware limitations and democratize AI access. This strategic divergence is creating a bifurcated global AI ecosystem, a digital iron curtain that separates US-led high-cost proprietary sphere from a China-led low-cost open-source sphere. The US model, while yielding world-class bleeding-edge performance, faces a long-term talent pipeline crisis as AI automates foundational learning tasks for junior employees. It also operates with a geopolitical paradox, as policies designed to contain China can financially harm US companies and inadvertently accelerate China's push for self-reliance. Conversely, China's open-source gambit, despite its reliance on less advanced hardware, has spurred a wave of architectural innovations that prioritize efficiency and resilience. By presenting its technology as a global public good, China is winning influence in the global south and building a massive, decentralized talent base that is more resilient than a centralized, elite-driven model. The AI race is therefore less about which nation has the most advanced model at any given moment and more about which development philosophy can build a more durable, influential, and resilient global ecosystem. Chapter 1. The rationale of a closed-source ecosystem. The United States' approach to AI development is rooted in proprietary closed-source philosophy. This model, championed by dominant tech companies like OpenAI, Google, and Anthropic, views advanced AI models not as a public resource, but as valuable intellectual property. The source code, algorithms, and training data are treated as trade secrets protected by intellectual property laws and kept inaccessible to the public. The rationale is that this proprietary control is essential for safeguarding competitive advantage and high-end innovation. One of the primary benefits of this model is centralized control over the system's evolution. Updates, improvements, and security fixes are managed exclusively by the developing company, which ensures quality, assurance, and consistent performance. This centralized authority also allows for the enforcement of use and misuse policies through defined interfaces and APIs, a key argument for proponents who claim it offers greater control and security than open system. This is particularly critical for high-stakes applications and compliance-driven industries, as it provides customers with a streamlined, off-the-shelf product with dedicated support services. The business model of a closed-source ecosystem is centered on direct monetization. Companies offer their models as a premium service with revenue generated through API access, tiered subscriptions, and enterprise licenses. This is akin to a Michelin-star dish refined behind closed doors and offered as a finished product. This strategy is designed to recoup the staggering costs of developing and training frontier models, which can run into millions of dollars. For customers, the justification for these costs is the premise of superior, ready-to-use performance and reliable without the need for significant internal investment in technical expertise or infrastructure. Chapter 2. The US high compute, high talent imperative. The United States' dominance in AI is underpinned by its technological superiority, particularly its estimated 2-year lead in producing cutting-edge AI chips. This is an essential foundation for the high compute demands of training massive closed-source foundation models, which have grown exponentially in size and complexity. Companies like NVIDIA, a major US exporter, are at the epicenter of this ecosystem, providing the hardware backbone for virtually all AI workloads. The business model is therefore tied to a continuous cycle of developing more powerful chips to train ever larger models, a process that relies on immense capital and a steady supply of top-tier talent. The reliance on high-end proprietary solutions has created a complex situation within the US talent pipeline. While AI tools are enabling remarkable efficiency gains for organizations, they are also automating the very entry-level tasks that have historically historically served as a training ground for the next generation of professionals. For instance, a marketing team may see a 40% productivity increase from AI-powered tools, but this comes at a cost of new graduates losing opportunities to develop the pattern recognition and contextual understanding that are crucial for building professional judgment. This creates a delayed feedback problem where the immediate benefits of automation mask a long-term strategic vulnerability, a vanishing ladder that could lead to catastrophic knowledge gaps and a dangerous reliance on powerful AI systems without sufficient human oversight. This erosion of foundational skills is a direct, long-term negative consequence of the short-term efficiency gains enabled by the closed-source model. The geopolitical dimension of this reliance on high-end chips is even more pronounced. The US government has used semiconductor export controls as a strategic tool to limit China's access to advanced technology. However, this policy has created an unprecedented and unusual situation. In a recent move, Washington eased some restrictions allowing US firms like Nvidia and AMD to resume sales of certain AI chips in China in exchange for remitting a 15% cut of the revenue to the US government. This arrangement transforms alleged national security policy into a revenue-generating mechanism, a move anti-China critics have called a dangerous misuse of export controls and a creative taxation scheme. This policy shift reveals a fundamental conflict between two competing US objectives: the desire to slow China's technological progress and the need for US companies to access the high-growth Chinese market to fund their research and development. Chapter 3. The philosophy of open source as a counter strategy. China's open source AI movement is not a mere technical choice, it is a strategic and geopolitical counterpunch to the United States proprietary model. The catalyst for this pivot was OpenAI's July 2024 decision to block developers in China, including Hong Kong and Macau, from accessing its ChatGPT models. This act, perceived as a national humiliation, spurred Chinese firms like DeepSeek and Alibaba to double down on an open source development philosophy. China has transformed the collaborative ethos of open source into an instrument of statecraft. By open sourcing its models, it has created a powerful, free-to-use alternative to the closed-off systems of US tech giants. This strategy allows Chinese startups to use contributions from a broader community of developers to accelerate development and bypass the limitations imposed by foreign dependencies. This strategic pivot is heavily supported by the Chinese government, which has explicitly designated AI as a strategic technology with a lead goose effect. Its 14th five-year plan outlined a top-down strategy to build local open-source communities and export innovations internationally. This coordinated state-led approach allows for rapid standardization and a cohesive national framework that is difficult to replicate in the more fragmented US innovation ecosystem, where any proposed standard is subject to intense corporate lobbying and political division. China's open-source strategy is a sophisticated form of soft power. By presenting its technology as a global public good and an alternative to the exclusive game played by Western corporations, China builds influence and trust, particularly with developing nations in Global South who fear being locked into expensive proprietary ecosystems. The choice to adopt a Chinese open source model over a US closed source one is therefore more than a technical or economic decision. It's an act of geopolitical alignment. Nations and developers who build on China's technological foundation will naturally align with its technical standards and, by extension, its government norms, creating a sphere of technological influence that bypass traditional diplomacy. Here's what I find interesting. According to Martin Casado, a partner of the venture capital firm Andreessen Horowitz A16Z, who stated in late August 2025 that around 80% of the US AI startups applying for funding use Chinese open source models instead of more expensive proprietary models from companies like OpenAI and Anthropic. This trend is driven by the superior performance, lower cost, and easier adaptability of leading Chinese open source models from teams such as DeepSeek, Ripple, and Qwen. Chapter 4. A cost-driven, community-leveraged ecosystem. The Chinese open source ecosystem is built on a foundation of cost efficiency and resourcefulness. Chinese models offer a compelling value proposition with inference costs that are 20 to 40 times lower than Western equivalents. For example, DeepSeek's R1 charges 14 pence per million input tokens, a fraction of the cost of OpenAI's ChatGPT 1, which costs $7.50. This pricing strategy is not a mere discount but a strategic weapon designed to democratize AI and enable enterprise to deploy large language models for tasks previously deemed too expensive, thereby gaining a competitive advantage through broad adoption. The disparity in access to advanced Western AI models has forced Chinese firms into a necessity is the mother of invention mindset. Rather than being a fatal blow, the hardware constraint has spurred architectural innovation. DeepSeek's V3 model, for instance, leverages a mixture of experts, MOE architecture, and other innovative techniques like multi-head latent attention to achieve state-of-the-art performance with a fraction of the compute power typically required by Western competitors. This focus on algorithm efficiency and homegrown hardware has made their models more lightweight and multi-domain adaptable, suitable for a wider range of applications and resilient to future supply chain disruptions. Huawei's Ascend 920 chip, for example, reportedly achieves 30 to 40% better training efficiency, with performance expected to surpass NVIDIA's H20, demonstrating significant progress in building a self-reliant ecosystem. This open-source philosophy also provides China with a powerful, decentralized talent advantage. Platforms like Alibaba's ModelScope, for example, which hosts over 70,000 open-source models, serve as a resource for developers worldwide, lowering the technical threshold and fostering collaborative bottom-up adoption model. The sheer volume of developers and derivative models, Alibaba's Qwen ecosystem alone has over 100,000 derivative models, creates a network effect that accelerates innovation far beyond the capacity of a single proprietary lab. This continuous feedback loop and community-based development act as a force multiplier, creating a massive distributed talent base that is more resilient and adaptable than a centralized elite-driven model. Chapter 5. The competition for global influence and standards. The AI race has become a strategic contest for global influence, with the US and China vying for technological hegemony through their respective development philosophies. The primary battleground is the global south, where a strategic choice has emerged for low and middle income countries. The US is attempting to extend its influence through public initiatives, public-private partnerships, educational exchange, or direct investment, but its proprietary high-cost systems are often torturous to deploy in regions with resource constraints. China, by contrast, is using its open source model as a powerful tool for outreach. Its low-cost open source sphere offers a viable and accessible alternative, allowing entrepreneurs in countries like Kenya, Ethiopia, Egypt, and Nigeria to build AI solutions to address local challenges in agriculture and education. This approach positions China as a technological partner that can help bridge the global intelligence gap, a message that resonates powerfully with developing nations. The choice to adopt a Chinese-developed foundation is therefore not just a commercial decision but a strategic one, with long-term implications for technological diffusion, data sovereignty, and geopolitical alignment. This strategic divergence is leading to a fractured global AI ecosystem. The likely outcome is not a single victor, but a world split into two technological spheres with different standards, supply chains, and software stacks. The US is betting that its lead in high-end innovation will compel nations to choose its proprietary systems, while China is using its open-source models to ensure that the next generation of AI applications is built on its technological foundations through a powerful bottom-up network effect. The competition is for more than just market share, it's for the very infrastructure and standards that will govern the future of AI. Chapter 6. Economic and national security crossroads. The AI rivalry is deeply embedded in the economic independence between the United States and China. US firms rely on the Chinese market for a significant portion of their revenue, and export controls, while intended to contain China, can backfire by cutting into their revenue and scale, making it harder to reinvest in the future research and development. For example, 21.5% of NVIDIA's total revenue in 2023 was generated in China. NVIDIA's 2024 revenue was up 114%. Imagine if NVIDIA was allowed to sell its latest AI chips in China. China imported $350 billion worth of semiconductors in 2020, more than oil imports. NVIDIA's revenue could have reached to unprecedented levels if it was allowed to export its latest AI chips to China. But the US government approach to more advanced AI chip export controls has created a complex policy dilemma, as evidenced by the revenue-sharing deal for chip sales, which attempts to balance national security with commercial viability. This constant policy flux pushes China China to accelerate its long-term strategic goal of self-reliance, with domestic chip share projected to rise from 17% in 2023 to 55% by 2027. China may not be able to achieve this goal. This is very ambitious, but here are some interesting projections. China is likely to surpass Taiwan's chip capacity by 2030. This is a major milestone considering the fact that over 90% of the cutting-edge semiconductors primarily manufactured by TSMC of Taiwan. Another report suggests that 50% of chips used in data centers in China will be produced locally by the end of this year, 2025. On a national security level, both nations are integrating AI into their military strategies, but they are doing so with fundamentally different approaches. The US military is using AI to strengthen command and control systems, while China has established a new information support force to coordinate network information systems and integrate cutting-edge technology like AI into military decision-making and combat. The Chinese system facilitates a seamless military-civil fusion strategy. This approach allows civilian advancements in AI, such as those from DeepSeek and Alibaba, to be quickly and easily funneled into military applications like big data analysis, real-time command systems, and drone warfare. This provides China with a critical national security advantage by leveraging private sector innovation and state purpose more efficiently. The US government, by contrast, has struggled to access private sector innovation for similar purposes in the past, but now the US government works with Google, XAI, Anthropic, and OpenAI to help the US military expand its use of advanced artificial intelligence capabilities. This dynamic also impacts talent development. While the US faces a vanishing career ladder due to the automation of entry-level tasks, China's open source approach democratizes access and creates a massive distributed talent pool from the ground up. This is a crucial long-term talent advantage for China that is a direct result of its open source philosophy and its ability to act as a force multiplier for innovation. So here's a conclusion. Navigating the bifurcated future of AI. The analysis of the US and the Chinese AI development approaches reveals a fundamental ideological divergence that is reshaping the global technological landscape. The United States closed source model, while effective for driving high-end innovation and securing intellectual property, is not without strategic vulnerabilities. Its reliance on premium hardware and a centralized business model makes it susceptible to supply chain disruptions and has created a paradox in which short-term efficiency gains may come at the cost of a long-term talent deficit. The US government's attempt to contain China through export controls have also had unintended consequences, accelerating China's push for self-reliance and complicating US own economic and national security objectives. China's open source gambit, born from necessity, has proven to be a durable and effective counter strategy. By leveraging collaboration as a weapon, prioritizing cost efficiency, and focusing on architectural innovation, China is not only building a resilient, self-sufficient ecosystem, but is also gaining significant influence in the global south. This approach positions China as a technological partner and an alternative to the proprietary high-cost systems championed by the West. The most likely future is not one of a single victor, but a fractured global AI market, a digital iron curtain where nations and businesses are forced to choose between two competing visions for the future of technology. For the United States, the strategic imperative is to reconcile its short-term commercial interest with its long-term strategic goals. This requires a nuanced approach to policy that protects national security without stifling innovation or ceding influence. For China, the challenge is to continue leveraging its open source momentum to overcome remaining hardware dependencies and establish its framework at the global standard. The ultimate winner of the AI race may not be the one with the most advanced chip, but the one whose development philosophy proves to be the most influential, accessible, and resilient. This is all from me today. Thanks for watching. Subscribe for more videos on similar topics. Smash the bell button, share and comment. Till next time, bye.